is probably eventually you may not need all models you have trained. Okay, like for example, we have our case for house value prediction. We have trained linear regression, ridge, and lasso. Then which model you want to select? Okay, which model you want to select? So here where you try to apply some assessment on the model in order to see which model is outperforming the others. Now using again the training data set is not proper way of doing it, because who knows, maybe the model is just overfitting the data. We don't know. So we need again unseen data, but looking back to the test set, we said we don't touch. So we're gonna see how we need to select using the validation set. I think should be here, model selection. Maybe just let me skip hypertuning for a little while since we're talking about model selection. So as we said, how to evaluate the model, test set, no, right? So we already agreed test set is not the proper way because we don't need to overfit our model to the test set. So here where we look into the validation set. Validation set, or they call it hold out validation, because you hold portion of your data from your training data, you put it aside for the purpose of applying assessment into your model. So this was the first stage earlier we saw where we created our test set and we put it aside for later time. You forget about it. Then you go to your training data set and further divide your training data set into training set and validation set. So you may call this the full training data set, if you like, full training data set. This is the full one that you have on your side. Okay, so you divide further into training data set and validation data set. So what do you do in the training data set? This one, so you use it to train your model. Okay, so you have, let's say, several models, linear regression, ridge regression, lasso regression, elastic net, whatever you have on your side. And then you apply evaluation or assessment using the validation set. Validation set shouldn't be included by any means during training time. So this is also considered as unseen data. Unseen data to the model. Okay, so the model has no idea what this data is. Okay, so a common approach to address this issue is to apply what's called hold out validation. In this method, you set aside a portion of your training data set as validation set, or some people call it development set or div set, to evaluate multiple candidate models and choose the best one. During the process, you train various models with different hyperparameter using reduced training set. Again, meaning we're talking about this, the reduced size, the full training set minus the validation set, and then select the model that shows the best performance on the validation set. Okay, like what we have done in practical 5, correct? Practical 5, where we trained several models. Eventually, we selected random forest because random forest shown the best performance. Okay. So how the process would be and overall, this is very important. So you understand the concept, how it's going to be. So again, we have the training set. As said, the dev set is just the validation, as mentioned just in the last slide. Validation set, and you have the test set. So what do? You start, number one, by training several models using the training set. Reduced size of training set. Remember, this is training plus validation is the full training set. The full training set. So you train your model using the reduced size of the full training data set. So you start with multiple model. Then second, you do evaluation using the validation set. Okay. So in this stage, as you see, you may go forth and back many times if you're not happy about the performance of this model. So you may keep going, looking into your model several times, maybe introducing new features, maybe removing outliers, maybe solving problems inside your data, whatever. Okay, so who's going to determine how the performance is increasing or decreasing? So you keep applying the validation set all the time. It's going to give you a good indication how your model is performing so far. Once you are happy, the evaluation is fine, you are satisfied about the evaluation of your model, then what do? Let's say this stage may take you a long time, okay? Because remember, test set is the last stage, but in order to move here, it may take you some time. Okay, so you may keep actually spending time a lot at this stage here. Keep evaluating, enhancing your data, introducing new data, looking into different models, doing feature selection, whatever. So you need to keep going through this process maybe for a long, long time. It depends, of course, on the complexity of the project. Okay, but the point is you have validation set on your side. So again, just I would like, since also some of you asked me earlier and we mentioned for your assignment, just you have your training and validation set. You don't need to create your own test set. Later, I'm going to pass you the test set, then just you evaluate your model, okay? So now for your assignment, you are here. You are kind of gonna be here at this section all the time, okay? Now, mainly actually, you're going to be here, mainly, okay? Because once you reach this stage, usually you don't need to go back. That means you are going to proceed to evaluate your model using the test set. So most of the time, you're going to spend your time in this section here, okay? Okay, so as we said, this is stage 2, stage 1, stage 2. So you keep training your model, evaluating until once you are satisfied, then what do? This is interesting part. You retrain your model. Retrain your model. Retrain your model using what? If you look the arrows, the full training data set. You train your model using the full training set. Because validation has already delivered its purpose, has already fulfilled its purpose to evaluate your model and so on. So that's it. Now you are happy, satisfied, and you need to have the final version of your model before you go for the final assessment, final exam. Then you retrain your model on the entire data set. Okay? So again, this is 2. Now you are 3 here. Then once you train your model, then you do the final evaluation section using the test set. Then after that, you need to go back. You see there's no arrow. You should resist going back to your model. That's it. This is why try not to use the test set until you are fully satisfied. Because if you do so, let's say you try to increase the generalization, reduce the generalization error, or improve the generalization performance, again, actually you are just trying to overfit your test set. And the results you are going to get may not be authentic, may not reflect the actual performance of your model. Like if a student is able to have a hand on the final exam question, then he attended final exam, he got A minus, B plus, whatever. This mark won't be really reflecting the actual performance of the student. Why? Because he may already just memorize the answers since he knew these questions are coming in the final exam. Okay? So this is what I explained already written here for you. So you train using the full training set and then evaluate the final model on the test set to calculate the generalization error. Okay?
So, these 3 steps, just for my knowledge, at first we need to have the training set. If the model is right for us, then we use the test set, and in case if it fits the model, then we will go for the full scale of that. I just want to test it.
Let me say again, it's not exactly like this. Okay, so we repeat about it. So the point is, okay, remember that previous slide we had, if we go to the previous slide here. So this is your data set, assuming this is your data set, the CSV file you have on your side. Then what do? You go and create your test set. You apply, let's say, random sampling, stratified sampling. You create portion, let's say 20% is here, 80% has gone for this one. So this one is the full training data set. This is the test set that we're going to use later. Now, how we can evaluate the model along the way if the test set, as we said, we must not utilize. Then we need to replace test set, or we find another test set which can be used during the modeling time, during the training time. So this is why we further reduced the size of the full training set into validation and training. So probably you are taking here 20% and 80% here again. Okay, so these two are going to be used for what? For training. Okay, and what? Training your model, right? Training the model, let's say first. And what we mean by during training, so you can apply assessment. Like you are as a student inside the class, you have continuous assessment. So I can use the validation set to assess you. Also, we can do model selection, right? As just we said earlier, you can do also hyper tuning. All of these can be used by validation set, the one that we have set apart. Now, let's say after you've done all this process, you are super happy about the results. Everything looks fine, perfect for you. Then what do? You do one more training, full training. Now this time you go back to the full training data set and you do full training. Full training means you use the full training data set. Once done training, then what do? You use the test set now to do the final evaluation. Okay.